Welcome to Ask and Learn.
So for problem 15.187, we'll be given some components of the velocity vectors for points A and B of the antenna. We'll be given the y component of the velocity for point A in inches per centimeter, and we'll be given the y component and the z component velocity at point B, and we've been asked to find the angular velocity and the whole value, the whole expression for the velocity at point A. Before we begin, we have to make two comments. The drawing might be a little bit deceiving. We mustn't infer from the drawing that the direction of the velocity, of the angular velocity, is towards the x direction. It can be towards any direction. And another point, it's clear from the description that there's no translational motion, and this fact makes our life much easier. So the relation relating the angular velocity to the velocity vectors for the 2 points is simply just the cross product of the angular velocity to the position vectors. And the same correspondingly for point B. Now, from the drawing, someone can see that the position vectors are just these. Point A, this is in inches again. Given this, we have to perform the cross products. And for convenience, we can do this in the form of a determinant. Let's begin with the first one. Let's rewrite the whole expression for the velocity vector expression for point A. And the determinant. And if someone does the calculations carefully, we'll get the following expression. For which actually we can already see that it isn't much useful at the moment because we cannot relate it. We have to compare these two components. And we have two unknowns and only one equation. So let's move on to the next relation, and we might be able to get more information from there. So writing the expression for the velocity of point B. Here we know two of the components. So we might be lucky this time. And if someone does the calculations, can get this result. So it might be obvious that we can start with the y component, giving us as a result, this is just 0.75 radians per second. Given the z component of the angular velocity, we can then go back here and check again the y component. Given that this is just 0.75, we can calculate the x component of the angular velocity. If someone does the calculations, you can see that this is just 0.6 radians per second. Finally, we need the y component of the angular velocity. And for this one, we can go back here. We know that one. And we have to compare this with this one. And someone can see that the y component of the angular velocity is simply 2 radians per second. Apologies, minus 2 radians per second. So let's write down the whole expression. This is the final result for task 1, task A. And then immediately for the velocity of point A, we just need to actually evaluate these two expressions. And since we have already calculated the y component of the angular velocity, we can immediately calculate the expression for the linear velocity of point A is just this one. And this is again inches per second, and that was radians per second. And this is the answer for task B of the question.